Okay, 8.1, 8.2, we're talking about the area and perimeter of different polygons. Okay, so this is an important thing to note. Areas of two congruent shapes will have equal areas. So two congruent shapes have equal areas, but two polygons with equal areas are not necessarily congruent. So for example, I have this triangle, we'll call it ABC, and this triangle, we'll call it DEF. I tell you that triangle ABC is congruent to triangle DEF, so that means that the area of triangle ABC is equal to the area of triangle DEF. Now, if I tell you that I have these triangles and I also have a triangle like this, we'll call it JKL, and I tell you that the area of JKL, triangle JKL, equals the area of triangle ABC, are those congruent? No. Triangle ABC is not congruent to triangle JKL. Not congruent. So, two congruent shapes will have equal area. Two shapes that have equal area are not necessarily congruent. Okay, so here are some shapes. Area of a rectangle. We know this very easily. We know that the bottom is our base, the side is our height, so the area is just base times height. It doesn't matter which one you use as the base or the height. The square, same thing. We know that this is our base and this is our height. They just happen to be congruent, so we can think of it as, instead of base times height, we can think of it as base squared, because we know that this one will also be the length of the base. Parallelogram, we know that this is the base. Now the height's a little bit different. We have to drop an altitude down, so that's where we make that right angle. And actually, if you notice over here, if I drop down this and make a right angle, this is our height. This piece right in here is congruent to this piece right here. So I really am finding the area of this rectangle that's formed. It's like cutting this off and pasting it right there. So it's the exact same thing. So the area is just base times height. Now triangles, we typically know, we know the formula is 1/2 base times height. We know that, but why is that true? Well, this is my base all along here. If I drop that altitude down, that's my height. Here's my height because it makes that right angle with my base. So again, these two are not hard. But then when you have an obtuse angle, this is my base here, but in order to find the height, I have to extend the base out and then drop down that altitude. So this is my height. The important thing to keep in mind is the height is always that piece that makes a 90-degree angle with that base. So this is going to be our height. Okay, we have a couple other shapes. Trapezoids, we know those very well. We know that those have two different bases, so base 1 and base 2. Again, we have to drop that altitude down, so that's our height. So what we're trying to do here is we have to figure out, so our area is kind of like our median formula. It's 1/2 the height times the sum of the bases. So we know that we can find, if we were to drop this down over here, it's also h. So we're really trying to figure out the area of the rectangle here and then these guys here. So in order to do that, we do 1/2 of the height and the bases. Now this is the same thing if our trapezoid were to be like this. This would be base 1, this is base 2, this is our height. The formula is still exactly the same. It's 1/2 the height times the sum of the bases. Now, area of quadrilaterals with perpendicular diagonals. We have two polygons that we know have perpendicular diagonals, and those are rhombi, so a rhombus, and a kite. So we're going to say that they have diagonals. We're going to call them D1 and D2. So D1, D2 are our diagonals. We'll call it diagonal lengths, I guess. Doesn't matter which one you label what. So this could be D1 and this is D2. This is D1 and this is D2. for whatever. So in order to find the area, we do 1/2 d1 times d2. So you multiply the two diagonals together, and then you divide that by 2, and that gives you the area of a rhombus and a kite. All right, last but not least, perimeter of a polygon is the sum of all the lengths of all the sides of the polygon. I went ahead and cut these two tables out of your book. These are in page 363 in chapter 8, so you're able to take a look there. Really, you don't have to memorize these. You know how to find the area of things. You know that you have to just add up all the sides. So this is just kind of breaking it down in a little bit of a different way. Same with a quadrilateral, a rectangle, a square, rhombus, and then a parallelogram. So either way, you can figure out how to solve this, even if you don't know these formulas. You know how to add them all up. So tomorrow in class, we'll take some time and practice using all this.